Hey, this is Adnan, and this video is intended to explain and clarify the concept of Anova, which is short for analysis of variance. Variance being the dispersion of data in a data set, which is used to attain the standard deviation. But before we can fully understand the implications of things like variance and standard deviation, however, we must first understand what an average, otherwise known as mean, otherwise known as x bar, is. So say you have four individuals who are in a class together and they all take a test. They all score differently because they have different skill levels, intelligence, etc. But what if you wanted to assess their performance collectively as a class? If you wanted to do that, you would have to level the playing field, so to speak, and make it as though each student performed equally well, even though they did not. In order to do this, one would have to tally, to collect, so to speak, the number of points scored collectively. In this case, adding to a total of 110. And then subsequently redistributing in equal quantities to the students. Since all of the quantities are distributed evenly, this tells one how the overall class performed. So say one wanted to see how Professor X performed as a teacher. You might take the average of students' scores on a particular test, in this case test 2, and the average should tell you how well Professor X taught the concepts and skills associated with this test, right? Not quite. If you went by the average, one would think that Professor X did a very bad job, but if you look at the individual scores, you'll notice that some of them are pretty extreme. Maybe this group that did poorly was absent when Professor X tried a new strategy that really worked. Or maybe this is normal random variance within a dataset. This difference may or may not be significant, and that is where calculating variance and standard deviation and conducting a test of significance can all be useful. Anova is one such a test, and it is used in specific circumstances. Say you have a data set that looks like this, and is analyzing the effects of the Summit Learning Personalized Learning Management System over time. There are three groups of students, and the groups to which they belong are denoted by the nominal values 1, 2, and 3. I would have to calculate the variance that exists between groups and within groups. I would then have to divide those two values in order to get an F-score, which is what is yielded by the ANOVA test, and the SPSS software can help us find that score. You can do that by going to Analyze, Compare Means, and then select the option for one-way ANOVA. Then you want to select the variables. The independent variable, which is the number of years that students have been involved with the Summit Learning LMS, will go into the Factor section. And the dependent variable, which is the scores on the students' summative cognitive assessments, will be placed in the dependent list. And once you hit OK, this report that gives the F-score will come up. Now there are other values here that were calculated, such as the sum of scores, degrees of freedom, and mean square that allowed us to attain the F-score, and I'm going to explain what those values are. The mean square to the left of the F-score is the variance that exists between the individual groups and within the groups themselves. You need to know this, as the F-score is attained by dividing those two values. But in order to calculate the mean square, we must first determine the sum of squares between and within groups. Let's start with the sum of squares within groups. The first thing you need to do is calculate the averages of the scores of each of the three groups. Those who have been exposed to the Summit Learning LMS for 1 year, 2 to 3 years, and 4 years or more. Remember, the average doesn't tell the full story, so we must determine how much each individual score varies from the average. This may or may not be significant. We do this by subtracting the average from each individual score. Then we square the differences of each one and add those squares together, hence the name sum of squares. Then we add those sums to give us the value seen in the report yielded by the one-way ANOVA test that we conducted in SPSS. If you divide that sum by the degrees of freedom, which is 6, you get the value of 21.778. Now let's do the sum of squares between groups, which is obtained by subtracting the mean of the values of the overall group, which is 85.777. We subtract this from the mean of the values in each group, squaring that difference, adding all of the squared differences up, and multiplying by the number of observations, or participants, within each group. You will then divide that value by its degrees of freedom to get the mean score of 401.444. Once we have those values, we can determine the f-score, as we will divide the aforementioned value by 21.778 in order to attain the f-score, which can help you determine if the variance is significant or not. More to come on that in another video.